Something special happens when you have a right triangle and you drop an altitude. Now, if you've forgotten, an altitude is when you make a vertical line like this, starting from one vertex and going to the opposite side. It creates a right angle right here. It actually doesn't even need to be vertical. You could have another altitude that looks like this, going from C to the line AB and intersecting with it at a right angle. That would also be an altitude, and there's another altitude this way if you want to draw it like that. But the altitude I'm going to focus on is the one that's drawn for us in this picture. Now, when you drop an altitude in a right triangle, it creates similar right triangles. It's kind of neat. I'm going to show you where these right triangles exist. Here's one similar right triangle, this red one that I'm drawing right here. And I'll put another one in blue. Here's the other similar right triangle. And if you remember something about similar right triangles, it's that their sides are proportional to each other. So I can say this. I could say the short side of the blue triangle divided by the medium side of the blue triangle is equal to the short side of the red triangle divided by the medium side of the red triangle. And now if I put some actual, numbers and letters on this, what does it mean? Well, the short side of this thing is CD, and the medium side is BD if we're looking at the blue triangle. And that's equal to, if we go over to the red triangle, the short side of the red triangle is BD. And the medium side of the red triangle is AD. Now what I've just written right here, this is kind of important. This is called the geometric mean theorem. You don't need to remember that name, but it is helpful to remember this relationship. If you want to solve the problem with it that we have, take a look at what we're given in the problem. We're told that the length AC is 40, okay? And we're told that the length AD is 36. That's even more useful. Let's label that 36. What integer is nearest the length of BD? So we want to know what BD is. Okay, I'll put that in black right here. This is our X value. And we're given 36 for AD, and we're also given AC, which is this long one right here. So if that is 40 and 36 is AD, then I can do some basic subtraction and say, okay, well that means CD must be 4. And now let's put these numbers in as best we can into our ratio, our geometric mean theorem here. If CD is 4, and I don't know what BD is, we're just going to call that X, and that's equal to X, BD, divided by AD. Remember, AD is 36. Look what we have. We have a ratio. There's only one variable. So if I cross multiply, I get 4 times 36 equals X times X, which is X squared. Now 4 times 36, okay, math, 144. 144 equals X squared. Well, that means X equals 12. Okay, I think that is what they were asking. Yep, that's what they wanted. They wanted BD. Now, in the problem you're looking at, you may have a different set of missing sides, and they might be asking for something different. But the important thing, what this all comes down to, is this idea right here. And that's worth memorizing for simple triangles. If you forget it, just remember the picture. I've drawn a blue and red triangle, and they're similar, which means the sides are proportional to each other.